Hi, I am Rajitha, working as an Assistant Professor of Artificial Intelligence and Data Science Department in SNS College of Engineering. Today, we're going to see about constraints in AI. What are constraints in AI? When we talk about constraints in AI, we are simply talking about rules or boundaries that an AI system must follow while solving problems. Think of it like playing a game. Every game has rules, and you can only win if you play within them. In AI, constraints are important because they help narrow down an possible solution to only those that are realistic and correct. For example, if we are designing an AI to schedule tasks, we can have a constraint that says no two tasks should happen at the same time. Our task must fit within working hours. Another example is in healthcare AI, patient data must be handled in a way that complies with privacy laws. So the AI must follow strict data rules. Without constraint, AI could give us answers that are theoretically possible but impractical, unsafe, or even illegal. By setting constraints, we make sure that AI is focused, efficient, and aligned with real world needs. The core components of constraint satisfaction problems, that is constraint satisfaction problem, are a big part of AI because they help in structured decision making. These problems have three main parts: variables, domains, and constraint. These are the variables, these are the things we want to figure out. For example, in a school timetable, variables could be the subject, teachers, and classroom. Domains, these are the possible values each variable can have. In our timetable example, the domain for math class could be Monday 9 a.m., Tuesday 11 a.m., etc. And the constraint is, these are the rules. For example, a teacher can't be in two classrooms at the same times, and a room can't have two classes at once. The goal of CSP is to assign values to variables from their domain so that all constraints are satisfied. This is used in AI for things like scheduling, resource allocation, and puzzle solving. uh, Visual puzzles piece metaphor. Here we can think about constraint as puzzles pieces. Each piece has a specific shape and it will only fit in the right place. In AI, constraints act like the shapes of puzzles piece. They guide the AI so that each decision fits perfectly with the others. Without these rules, the puzzles would never be completed. This visual is powerful because it shows that constraints are not about limiting creativity, they are about helping things fit together in the most efficient and correct way. Four key constraints in AI deployment: governance, security, privacy, and compliance. Governance, making sure there is accountability and transparency in how AI makes decisions. And the security is protecting AI from hackers, malware, or any misuse. Privacy, keeping sensitive data safe and following law like GDPR. Compliance, meetings legal requirements which may vary across countries. If these constraints are ignored, AI can cause harm, face legal troubles, or lose user trust. By following them, we ensure safe, ethical, and legal AI deployment. And the case study is AI driven fraud detection. In this example, an AI was built to detect fraud in financial data. The main problem was that traditional systems were too slow and causing millions in losses. To solve this, AI constraint was very specific, focused only on detecting fake numbers using something called Benford law, which checks for unusual patterns in numerical data. By narrowing the AI scopes, it becomes faster and more accurate. catching fraud almost in real time. This shows that when you define clear constraint, AI can be more effective and practical. Technical constraint, data and computations. Two major techniques constraint in AI are data quality, computational limits. If the data is biased, incomplete, or spread across silos, a result can be inaccurate or unfair. Computational limit is AI, especially large models, needs powerful computers and a lot of electricity. Possible solution include improving data governance, creating synthetic data to fill gaps, and using AI-powered cybersecurity to protect data and system. And the creativity through constraints, sometimes constraint actually boost creativity. For example, when AI language models were tested on old 1980s hardware like the Commodore 64, they had to work with very limited memory and speed. This forced developers to think differently and find innovative solution. The same thing happens in art. Haiku poetry works with strict syllable with strict rules, and jazz musicians improvise within musical limits. In AI, constraint can lead to unexpected creative break. And the overcoming constraints. Finally, overcoming constraints is about using smart strategies to unlock AI's full potential. Strong governance Strong governance and secure system like air-gapped environment, AI enhanced cybersecurity to stay ahead of evolving threats, strong privacy measures with encryption and regular audits, clear problems definition so that constraints are realistic and actionable. When we balance constraint with flexibility, AI becomes both powerful and trustworthy. Thank you.